Good afternoon, everybody. Welcome to this meeting of the Royal Statistical Society's Professional Statisticians Forum. Easy for me to say. My name is Rob Domenico, and I'm going to be chairing today's meeting. I am a member of the RSS PSF, and there are many events like this available on the website. If you haven't ever dialed into one before, I recommend you check them out. Our presenter today is Dr. David Hastie, Director of Sporting Data Science, who will be talking on working as a data scientist in sport. So I'm very pleased that Dave's here today. Dave is Director of Sporting Data Science, which he set up in 2015. I've known Dave for a long time now, since the days that he worked in Smartodds. He was my first boss, my first job. And Dave's had a really good and interesting career. I'm not going to go through it in too much detail now, because that's all going to be covered in his talk. Aside from Dave's work as a sports scientist, data scientist in sports, he's also involved in the RSS sports section, and is involved in a variety of roles, of which he's currently chair. Having read this talk, I think it's going to be really interesting. So with great pleasure, I'll hand over to you, Dave, and Dave can give his presentation.
Thanks very much, Rob. And thank you, everybody, for spending some of your time this afternoon listening to me. Very kind of you. I'm going to crack straight on with the talk. So I'm going to go straight into slide number 2. Basically, my first few slides are going to be a short introduction, basically convincing you to invest the next hour of your life. I hope I can convince you to do that, but the benefits of a webinar, which this is my first, is that if you don't want to do that, you can just sneak off quietly and I'll never know. I'll quickly go over my statistical background, then I'll go over my business background. Hopefully that will show that I do have some credibility to be here, but you can judge that for yourself. And then I'll go over really the main body of what I'm going to talk about today. So moving on to slide number 3. So my statistical background seems a long time ago when I wrote it down on paper, but 20 years ago I did an undergraduate degree at Bristol. It was in mathematics, it's a 4-year degree, and they gave it some fancy title. But in the last couple of years of my degree, I focused largely on statistics and found my calling, as you might say, and did a lot of computing and statistics modules. After that, I went on and did a PhD in statistics. There's a missing year there, which is a year of life as an actuary, which we tend not to mention anymore. But the PhD in statistics was from 2001 2004. I specialised in market share Monte Carlo stuff, which was quite fashionable at the time, maybe a little less so now. But really my main research interests were methodological interests, and thinking about how to design generic software, performance software that could be applied to a number of applications. I didn't have any real sporting applications at that time. I should also mention that in between some of the industrial, some of the business experience that I'm going to talk about in a minute, I also came back for a short stint as a postdoc at Empirical between 2010 and 2012. Again, entirely irrelevant to this talk because it was nothing to do with sport, but I suppose it did have some computational aspects to it. So moving on to the business side of things. I've got to remember to press the button rather than my arrow key. So I'm on slide number 4 now. My business background, I did a stint, which if you're paying any attention, you'll notice that overlapped with my PhD. I started out part-time working for a company called Smartodds, and I'm not going to go into a lot of detail on this slide on what each company did, because it's covered in quite a lot of detail later in the talk. But I ended up heading up the quantitative team there, which is where I was lucky enough to meet Rob and a number of other people. I then set up my own company after my postdoc, a company called Onside Analysis, which then became Stratagem Technologies. And more recently, I've been working for a company called CricViz and my own new company, which is Sporting Data Science. So what are we actually going to talk about? Slide number 5. So what I wanted to do today really was to basically give a talk about being a data scientist in sport, really by case study a little bit. So talking through my career highlights of the various places that I have worked, and then basically pulling that all together at the end, talking about some of the kind of common themes and best practices that I've experienced, and some of the common challenges. And if you did read my abstract on the website that Rob mentioned, a couple of the things that I wanted to touch on were really kind of empirical models and model assessment, and I will spend a little bit of time on that. The talk's going to be relatively high level. There's, I think, one equation in the whole thing, so if you're expecting a highly technical talk, then I'm sorry to disappoint. If you're not, then you can relax. My final part of the talk will be covering my perspective on the future, which will really kind of bring in the stuff that I'm doing with sporting data science at the moment. So without further ado, I will crack on to slide number 6, and I'm going to start with these career highlights. And I've kind of subtitled this what I do, or what I like to tell people I do. I sometimes tell people that I do sports modelling, and they look at me funnily because if you can see me, which is the benefit of the webinar that you can't, they think you can't be a model. That can't be right, and they're right. Yeah, I'm not a model, but I do sports modelling, and it's the one thing that keeps people interested at parties. So on to slide number 7. Smartodds. So I worked. This is probably my longest position that I've had in this area, where I kind of cut my teeth, and it was between 2003 and 2010. I'm going to start by talking about what the company did. Basically, the company was trying to analyse sport, and mainly in the time that I was there, it was football, and they were doing that to identify opportunities where they could place bets which would have a positive expected return. What does that mean? Place bets where they would win money is essentially what it means. That analysis was statistical modelling, which was the part that I want to talk about, which was a large part of what we did. But there was also a whole load of other things as well, a lot of qualitative research, and the company kind of layered it all on through some very talented individuals who are kind of acting like human Bayesian machines. So I've written an equation. Actually, I said there's only one equation. There's 2 in the whole thing. So this is the only one that doesn't have an error in, I believe. So this equation here, consider that there's an event G that is an event that we want to place a bet on. So some examples might be Team A, let's give them a particular name. Manchester United are going to win in their match next weekend. So that's an event G that we want to that we may want to place a bet on. Now we might also have some bookmakers odds, and I've denoted those by X. Now these are odds written out in decimal form. It's a technical betting term. I'm not going to go into the details, but it's not like 2 to 1 or 3 to 1 or 4 to 1, but it's actually a slightly different way of writing out the odds. Once you combine your odds with the probability of the statistical model that this event is going to occur, and I've denoted that by P, some kind of statistical model, then you can basically work out what your expected return is. That's the left-hand side. And what we were trying to do was try to make sure that that was greater than 0. So our job as statisticians there was basically to work out the P, to work out the statistical model, the probability of the event happening, and to do that better than the bookmakers who were setting the odds, or to do that in ways that we could identify where the bookmakers were getting it wrong. So that was the whole premise of what the company was doing. So moving on to slide number 8. Smartodds started very small. It was actually myself and another data scientist, another statistician, who were doing it part-time as we finished our PhDs, for someone who'd come out of the financial industry and had done a lot of trading on financial products and wanted to look at doing similar kind of things in sports. He had some experience of doing it in sports as well. So we were doing this on the side. Actually, by the time that we finished, we'd grown into something a lot more formal, and now the company still thrives and has a very big data science, well, a moderately big data science team, big for the industry, of kind of 15, 16 PhD level data scientists doing similar similar things to what I would describe now. What we were typically doing back then was a bit of data processing, and what that involved was basically taking many different sources of data, and sporting data comes in lots of various different unstructured formats. Some are structured, some are nice data feeds, XML feeds, some are not. Some are literally web scrapes or various bits and pieces like that. And we were trying to take as many bits of historical information as we could and automate that whole process and clean that data, link that data, and build pipelines basically to analyze that data. Now, by pipelines, what I mean, and this is a term I'll probably come back to a little later on. By pipelines, basically what I mean is everything all the way through from ingestion of the data or identifying the data, ingestion of the data, storing that data, linking multiple different data sources, inputting that data into various different analyses, statistical analyses for reports or empirical analyses, and then entering it into a kind of model development cycle, which I'll talk about in a second, whereby the output of that cycle could be, again, stored in an automated manner and then be used to inform decisions and decision makings by whoever was actually the end user. The model development cycle was really the kind of the key other aspect, apart from the data processing that we were responsible for. The key thing for model development, like anything, is to reduce the time around the cycle. So essentially, if you look at the right-hand side of slide number 8, it starts at the top, but it is a cycle. So before you start, it may not be feedback, it may be an idea. You may have some expert in the domain who has some kind of idea. He thinks that, for example, Manchester United, I don't know why I keep mentioning that team, but Manchester United are not being priced correctly in the market. Perhaps they have too many fans. They're well supported, and so there's a lot of money backing Manchester United, so that they're not well priced. So that might be the hypothesis. That would step through to us through to a data analysis. We'd look at our data, look at the raw data that we got to see whether there was actually any evidence of that. We would then kind of pair that up with any academic research that was out there. So looking in the journals, looking at what people were writing about sports modelling, football modelling at the time. And at the time, there wasn't a great deal. It's very different now. There is more academic literature, and there's actually a lot more development in this area in sporting modelling, but at the time there wasn't much. We would then kind of combine those two things, the data analysis and the academic research. We would develop a model, and that would typically be quite a computationally intensive model, and then we would assess that model. And that whole assessment question is one that I will come back to at the end, and what that actually means. We'd report, if we thought it was favourable to utilise the model, then we would put that model into production, and that's a step that is often overlooked within a business context, I find, in terms of people often think about the research stage and actually developing the model, but actually there's a significant part to actually put a model into production, to automate it so that it's all running with minimal user intervention, or user intervention in a controlled way. So that was kind of what we did at Smartodds. Moving to slide number 9 is an example of this. This is my second equation of 2, and this one does have an error in. So basically, it's a great equation because it has no context. So I haven't told you what any of the quantities actually mean. So in itself, it's not that useful. But let's consider a football match, because this is what Smartodds did. And let's suppose that the number of goals that the home team, which we will label Team J, the number of goals that they would score in the match. Let's call that X. And Y, that is the number of goals the away team, and that's where we've got an error. Y is the number of goals that the away team would score, and they're the team labelled by K. So basically, the model, the most basic model that kind of we started with when we started out in 2003, was a model published by Dixon and Coles, which said that the mean number of goals the home team would score was some kind of global scoring rate that was advantage for playing at home, which is denoted by gamma in this equation, then some constant that was, or some parameter that was to do with the attacking ability of Team J, plus some parameter beta that was to do with the defending ability of Team K. And then the away team, the number of goals that they would score was a very similar thing, but it was their attacking ability and their opponent's defending ability. And that's the error in the equation. The y should be Poisson distributed with lambda A, not lambda H. So basically, the very most basic model there suggests that the goals are independent. They're independent Poisson distributions, and it's a big computational model where you've got many teams playing a lot. You've got a lot of historical data, and you're trying to estimate the various number of parameters. That in itself, as a model, if you try to go and take that to the bookmakers and make money out of it, they would love you. Because you wouldn't make very much money at all. But at the time, it wasn't so far away from being a good robust model because not many people were doing robust modelling for sports betting. We extended that model in all kinds of different ways while we were at Smartodds. Some of the things that we thought about were the dependence between X and Y. So actually, the number of goals that one team scores or the both teams score are not independent processes, quite obviously. So thinking about those things were on our list of things that we thought about and how we might take account of that. And then there were things like temporal dependence. So teams are not typically static in their abilities. They vary over time, and so you might have to think about how alpha, the attacking parameter, or beta, the defensive parameter for each team, would change over time. And then there were other things like additional count data. So we had shots, corners, chances, things like that, because not all 1-0 games or all 2-all games are exactly the same. Football is a very low-scoring game, and actually the number of goals in a game don't necessarily tell the whole story behind the game. And so there's all kinds of other data that may be very interesting to take into account that may give you a better predictive model when you're trying to predict the outcomes of games you haven't observed yet. And so extending the model to take into account of those various different data factors was another area of research. Player data is another one where you actually extend this model beyond teams and start looking at which players were playing, and then various other factors like environmental data, such as the pitch, the weather, the distance the team has travelled. So some really interesting lines of inquiry and research as we went through that. So moving on to slide number 10, onside analysis. Smartodds I covered that in a little bit of detail because it kind of forms a lot of the basis for everything that came subsequently. Onside analysis was the company that I set up, or I co-founded after Smartodds and after my postdoc. And our real aim with onside analysis was to do very similar kind of modelling, very similar kind of analysis, but not necessarily to do it just for betting. So we could see lots of other applications that may be interesting in and around football and the football industry, so to various different stakeholders. So some of the things that we looked at were working with professional clubs and thinking about how they might assess their players, how they might determine the abilities of the players, and that would be obviously pertinent for recruitment or for salary negotiation, and a similar kind of thing for football managers, where there is often a very high turnover and it's often very subjective. We would try and do some analysis to determine some data-driven decisions to recruit managers or to retain managers as much as anything. So we did a bit of that. We did a bit of technical analysis as well. So for some of the confederations, they hold big coaching workshops, and so we would use the data and the statistics to kind of provide information to the coaches to kind of illustrate trends or things that various different teams were doing to sessions, by the time we finished, betting came right back into the fray, and we were spending a lot of time doing betting stuff as well. So, how do we use data science? This is slide number 11. It's very similar, really, to Smartodds. We did quite a lot of our own data collection as well. So to add in another kind of layer before the data parsing and the data processing, we're actually collecting our own data. So we had lots of experts, sports scientists who were collecting data, who were prepared to collect data that a lot of the major sources of data, like Opta or some of the other companies were collecting, would not collect. So that was typically data that was subjective, and we were prepared to put that into models because subjective data was actually very illustrative if it could be collected in a rigorous way. So that data collection and that design of the data collection, I think, all falls under the data science remit. And then processing that and linking it to all the other data that we had was also part of our work. Again, statistical modelling, similar kind of things. Reports, visualizations, I guess these were a much more significant part of our work at Onside Analysis, whereas for Smartodds, it was often to determine whether there was a bet or not. Didn't need to see a fancy graph to decide whether it was a bet or not. They just wanted a binary yes/no. Actually, the end user of a lot of our analysis consumed the data in a different way and were very interested in looking at graphs, looking at trends, looking at various different aspects more visually. And so that formed quite a big part of our work. And that kind of extends beyond kind of static reports to web dashboards and other ways of delivery. So on slide number 12, I've given an example of some of the stuff that we actually did. This was some work that we actually did for a particular club. We used some Opta data, where Opta collects basically every touch of the ball in a football match. And not only do they timestamp that data, but they actually code it in a particular way. It's a very labour-intensive data collection operation. Very impressive if you ever get a chance to go and see it. But it leads to some very rich data where you can tell what happened literally with every pass of the ball, every touch of the ball. You can track it through the whole game. So we use that data to try and assess the contribution of players, and we split that into three categories. We like to think of players making a contribution to their teams either by scoring goals themselves, because obviously the objective of a football match is to score a goal, or by helping their team to score goals. So their primary role within a team may not be to score the goals. It may be to assist their team in scoring goals. So they may be making a significant contribution in that respect, or they may be making a contribution by preventing the opposition team from scoring goals. Now, the first thing I'll just touch on, I'll touch on something here for the first time, which I'll return to later. This kind of work actually leads to quite considerable credibility challenges, and one of the biggest ones that we found was actually there's quite a disconnect between the people who embraced this kind of work, who were typically the analysts, and in our case for this actual piece of work here was at the kind of C-level. I think it was the director of football operations or something like that who commissioned this piece of work, and actually the coaching and playing staff, and so that disconnect means that it's quite difficult to make sure that the work that you're doing, or to present the work you're doing in a way that actually has results that are practically useful. And I'll talk about that a little bit later on. Opta data, that's an imperfect data source. Again, I'll talk about that a bit later on. I'll expand on that. But it does, even though it contains every single ball touch, actually a lot happens in a football match that is not a ball touch, and without that, you can sometimes struggle. And probably the biggest thing is actually if you develop a model that has even some of its outputs which are implausible, you can lose incredible amount of credibility. It can be enough for your model to be completely dismissed because there is a real reticence to embrace data-driven thinking, or at least there was 5 years ago. So that was a significant challenge. The example here on slide 13, I've given a kind of an extract of the report that we prepared for the club. In question, it's got some details about how we were kind of coming up with thinking about measuring players. I'm not going to go through these in detail. There's some quite esoteric kind of recommendations, but we've given it quite a lot of thought, and we're trying to convey it in a way that was easy enough to understand why we were including various different things. But ultimately, what we were doing was we were coming up with essentially an index for each player's contribution. And on slide 14, you can see one of the teams, I think it's Chelsea in this case, in the Premier League between 2012 and 2013. And these are the players that played in their squad during that time. And these were some of the values that we'd attributed to some of the players. And I'm not going to go into the details of how we actually did that, although a lot of the factors that we considered are in the extract on the report on the previous page, although not with combinations. So that was the kind of thing that we were doing at Onside Analysis. Moving on to Stratagem Technologies. Stratagem Technologies saw what Onside Analysis was doing. Their background was as a group of financial traders who had been very successful trading financial assets and saw sports betting as just another asset class. And so we actually sold Onside Analysis to Stratagem Technologies, and I started working there for a year, helping them to take the analysis that we had done for various different stakeholders and actually turn it into something that they wanted to do to kind of trade a different asset class as financial traders. So if we look at what they describe, what they do on their website, Stratagem Technologies, they basically consider themselves to be generating consistent edge in sports prediction trading, which is a highly liquid asset class with uncorrelated returns, consistent edge in sports prediction trading, a highly liquid asset class with uncorrelated returns. Well, that's interesting. That's a really bad quote that I never checked. Maybe I typed that out incorrectly. I'm doing exactly. I've got a duplication there. I suspect that I've done them a massive disservice. And if you actually go to the Stratagem Technologies website, there you'll find a much better quote that actually says what they do. But essentially, the premise is tied up there. They're trying to trade sports bets in a way that you might typically think about trading financial markets. So where is there a similarity to Smartodds? Actually, the approach is much more inspired by financial trading. They think about building portfolios, they think about trading strategies, and they think about risk management. Smartodds were very much thinking about modelling the underlying event, and then applying that to a handful of bet types. Stratagem thinking about building up portfolios of quite non-vanilla various different types of bets and trading strategies. So the things that the Stratagem are doing, they've developed a trading platform to allow people to utilise to do their own trading. They're running their own proprietary trading fund. Sorry, they've got their own trading fund, proprietary trading fund, and they've also got a managed fund where they manage other people's money. So slide number 16. How was data science used there? Well, a similar kind of thing, data pipelines, statistical modelling of the sporting events, what we've seen before, but this time there was also some modelling of odds time series as well. So because they were much more interested in the trading strategies, they were using a lot more time series methods, some really interesting machine learning, reinforcement learning stuff that was coming out of, or was in combination with the work that was being done at UCL, and applying some really interesting algorithms there to the actual time series of odds rather than the underlying sporting events. And then various different mathematics and statistics to do with portfolio optimization and various other things. The other thing that they were doing, which I will use as my example on slide 17, was a bit of image processing. And this started out as a master's student project that I kind of dreamed up while I was leading the team and talking to the guys at Empirical College. What we found is that actually we know that it's very useful to collect our own data. There's data that, as I said earlier, that is subjective that people don't want to collect. But manual data collection is a very, very expensive thing. So we were looking to see whether we could automate that in any way. And so we dreamed up a project where we would basically use image processing to collect the data, but to collect the data in a way that we wanted to use it, just using normal television feeds. And really the ultimate aim of the project, although it became a full-time research area, still hasn't addressed this, was to categorize different types of shot. So, for example, what we might typically see from a traditional data collection source would be a shot on target or a shot off target. But the shot on target might be a shot from the halfway line at the last hit of the game, where every other player is between the ball and the goal, or it might be a shot from 5 yards away from the goal where there's no one in front of the goal, and they're very, very different events. So actually being able to kind of categorize those by essentially the probability that the shot might result in a goal is a significant area of interest for a lot of people working in this area. So we were trying to do image processing for that purpose. Now, sadly, I can't show you the video, but if you look on slide 18, there's a still from the video. It's only an 11-second video. But we got some way with it. We were able to identify all the players, we were able to identify the goal, and we were able to track the ball. And if you search on Vimeo, or even go to the Stratagem Technologies website, which is www.stratagem.co, then they've got an example of this running for 10-15 seconds, where they were actually kind of doing the image tracking. But obviously, there's a considerable amount of work to do to take that to the next stages. But it's a nice example of something that's a bit different to the data science that we've been doing at other places. So, moving more closely to the present now, on to slide 19, which is CricViz. This is a company that I've been, I've been working for really over the last year, and I'm still a director there, and I'm still a consultant there. CricViz basically wanted to change the way that cricket was consumed, either by the real passionate fan or by people who really weren't fans of cricket, who found it very difficult to enter the game of cricket and to understand what was going on. So really, it started out with the question: when you're watching a game of cricket, how can you tell which team is winning? And because cricket's a very difficult game to kind of understand, especially a test match, which is a game over multiple days. Each team has multiple innings. It can be quite difficult to determine which team is actually winning. So CricViz kind of started out with that question, but then started thinking, actually, there's quite a lot of rich data out there. How can we make this more interesting from the very kind of traditional scorecards that is really the only way that fans can consume sport at the moment? And that started out kind of building out a data-driven community, and extended to kind of provided those services to broadcasters, to professional cricket teams, and into the betting industry as well. Data science was used in a very similar way to everything that we've talked about before. So on slide 20, again, pipelines. The company built a lot of its USP was in and around aggregating data that other people had, but not together. So actually aggregating multiple data sources, and that combining of data sources, that linking data sources, is something that people underestimate as being more trivial than it actually is. It can be quite a difficult step, and you can gain quite a lot of value by doing that. We did a bit of modelling as well. This visualisation and disseminated data as well. So on slide 21, this is kind of an example of what we were doing. The output that we created first off was a mobile application whereby fans could basically track during the match what was happening in the match, what our predictions were. That was in terms of who would actually win the match. This is the recent England match against India, and the length of each innings as they were predicted. And then we had various different other modelling aspects and data analysis aspects that were more descriptive modelling rather than predictive modelling to kind of describe how players had been performing up to that point, to describe how difficult the batting conditions or the pitch conditions were based on ball tracking data. So that was typically data from companies like Hawkeye or a company in Australia like Eagle Eye that also provide ball tracking data. And so we needed to have quite robust data science underneath all of this to make this work on an ongoing basis to support a mobile application. Similarly, on the example on page 22, we provided these services to broadcast, and one of the things that we did that no one else had been doing basically was collect some bespoke fielding data, and we were looking at the impact of the various different events that a fielder might do, whether they were positive or negative. And we provided that to various different broadcasters around the world. We do provide that to various different broadcasters around the world. So let's bring this all together, and that's kind of the case studies part of the talk, and talk a little bit about the common themes and best practices. I'm kind of aware that I've only got about 10 minutes left. So in terms of the common themes and the best practices, I guess the main positive thing was the fact that we want to have robust practices, and I think this is slightly different to academia, certainly in my experience, whereby in academia we get nice data sets that are kind of given to us. We might have to do a little bit of processing ourselves, but they're rather static, the data sets that we're working on. And I guess that's the difference between the business applications, certainly, that I've worked on. The data isn't static, it's always changing. And certainly in sport, there's a lot of sporting events, they're always changing. Players are changing, teams are changing, abilities are changing, and it needs to, there's new events all the time that need to be refreshed, and everything needs to be kept up to date. I have found that the only way to do that is to use databases. It's not something that I've found widely used within academia, within the statistics departments in academia. That I use that maybe because I'm 5 years out of date within academia now, so I can't really comment, but I would say that they're an imperative part of doing robust data science, certainly for sports modelling. And actually taking ownership of the data processing is something that I think is really important. What I've come across in a lot of companies where I've come in post hoc after the company has been set up is that they'll use the same software development team to do the data processing as they would to build their website. And actually the data is of much less importance to a website than it is to someone who wants to do statistical modelling or data analysis with. And so if you don't put a high degree of concentration and attention into processing that data, and I would say that it's nearly 50% of the work that I do, you get the old adage of rubbish in, rubbish out. Your models literally just return nothing. So it really is worth the time investing in that data processing pipeline. The model development framework, talked about that a little bit. The key thing for me is to make it repeatable and reproducible, and make it easy and quick to test hypotheses. So this often takes a lot of time to set up from scratch to actually build the framework, but then actually once the framework is built, it should be very quick to test a particular model. Is it better? Is it not better? And it's really important to record failures as well as successes. On to slide 25. The other thing that I really kind of encourage is pragmatism. I call it pragmatic rigor. Basically, there's various different ways that manifests itself, but key point is don't just discount things because they can't be proven statistically or because some assumptions may not hold. Ideally, we would love these things to hold, and ideally we might pursue and invest some time to trying to extend the theory. But in practice, things are often much messier than we come across in theory. So we have to just see how it works and adopt a pragmatic point of view. Remember the final goal, while all the while trying to make sure that we understand the limitations of what we're doing, and if we are going contrary to assumptions or that underlie various different results, making sure that we are aware of that and making sure that our users are aware of that. The domain credibility challenge. One of the things that I mentioned a bit earlier on, this is one of the challenges that we have, especially in sports. Athletes and high-performance athletes and coaches are typically not necessarily educated in an academic sense. They've got their own kind of intuition and experience, which tells them and creates their own expertise. And it can be quite difficult, I think, to marry the two and to tell a convincing story to convince them that actually the approach that you can drive through the use of data can add to their experience. I don't think that's unique to professional sports. I've seen very similar in betting, and I know of good friends who've actually tried to do similar things, trying to predict whether a record, a piece of music is going to be a hit or not. They've met very similar kind of challenges, but it is definitely a real challenge. I mentioned before that actually, if you get it wrong, then it can be very punitive. You can be really penalised by the fact that you have got this reticence to use these data-driven approaches. So when you do kind of put out that really doesn't put a pass the plausibility test, it really can be quite damaging. And that can be a real problem in professional sports, where perhaps the idea is player recruitment, and you may recommend that a team recruits a particular player, and that might be on the basis of some large sample kind of analysis and general ideas, but they're really only going to recruit one or two players in a year, and it may take several years before they're actually that decision bears out whether it was a good decision or not. People will often judge it on a small sample size on a short time frame, so that can be quite difficult. I think the piece of advice I have for that is basically you've just got to be professional about it, and you've got to obtain gradual buy-in. And by that, what I mean is essentially the best way to do that is to kind of match people's current understanding. So show how you can demonstrate the same thing with your data-driven analysis. So you're not really adding anything there. You're just getting buy-in. And then work to scale that to show, okay, well, I can produce exactly the same as what you can here, but actually by being able to do it using data and being able to do it in an automated way, I can do it on a much wider extent than you can do it manually. And then when you've got that kind of gradual buy-in, then what you can do is you can extend it to add new insight. And I think it's that kind of process that is useful. On to slide number 27. Data matching, I'm not going to say too much about that. It can be a challenge, but it's not perhaps the most interesting challenge. Slide 28. Incomplete data, as I mentioned before, is a challenge. Defending in football is a particular example of that. Often a defender doesn't actually have any ball touches. He may be just very well positioned, so that an attacking player decides not to attack where that defensive player was, and no ball action was actually ever recorded for that defender. And so that can introduce biases if you don't take that kind of thing into account. So there's various different issues like that need to adapt when you're adapting your parametric models to kind of take account of these limitations in the data source. So model assessment, this is one of the things I did want to cover. I am very aware that I'm running out of time. But one of the challenges, I think, for model assessment is basically that it's actually quite hard to decide whether one model is better than another. Now, first of all, what you need to have in place is a robust framework. Now, we'll talk a little bit about that, about the model development cycle. When you're assessing a model in a sports modelling environment, they typically need to be, which is a relatively dynamic environment. There's a lot of games that changes. You need to have a consistent data set for actually assessing things. So that's part of this robust framework. You need to be able to reproduce your results quickly enough. So reproducible research is really important. And this whole kind of assessment does need to be an integral part of the kind of wider model development pipeline. And I would hugely recommend through this experience that you document your failures as well as successes. Otherwise, you end up repeating experiments several months or years down the line, basically. So that's often a step that people miss out. But the biggest challenge for model assessment is asking the question, how do we measure success? And I think it's probably not a challenge that's isolated to sports modelling. But there's often lots of competing candidate measures. And so we need to work out what the best one might be. And there's often the question of, can we isolate the model from the ultimate outcome? And so I think the best way to illustrate that is through examples. So I'm going to talk through an example on slide 30. Suppose that we were trying to think about modelling a tennis match. Now, the most simple kind of tennis match model, which can be an in-play model, is a kind of a Markovian model. So the probability of winning a point only really depends on what the situation is. The current score, it doesn't depend on the history of the scores. That's a very simple model. You can extend that quite considerably to be non-homogeneous, simulation-based. But these models can update after every point, and they can be extended in various different ways. So if we can come up with a model, how do we assess how good that model is? Well, if we're trying to model something in play, we've got the question of, when do we assess how good the model is? Do we assess it at the start of the match? Do we assess it at the end of the match? Do we assess it after each set, after each game? Or is it some combination of those? Is it some integrated quantity that takes account of how good it is throughout the whole period? And actually, yes, the probably answer is it is some integrated quantity, but it's non-trivial to actually come up with what that quantity might be. If we can agree on that time frame, we can agree on a certain point where we want to assess it at, what do we actually measure? Well, we probably don't want to just measure bias, obviously, because it cancels. So is root mean square prediction error better? And we take that and refer that instead of bias? Well, it's probably better to an extent, but we certainly don't want to just get a very biased model by minimizing, or we don't want to introduce bias where we might otherwise avoid it. So there's some kind of trade-off between root mean square error and bias. And we might want to think about other measures as well that aren't necessarily kind of an observed minus expected based measure. They might be likelihood-based measures or other measures. So as you can see, there's lots of different criteria, and I'm not here to say which one is best, which one I prefer, or otherwise. But the question of which one to use is a tricky one. And then you might think about, well, what actually is this model being used for? It's being used for betting. Okay, well, should we be using root mean square error at all, or should we be thinking about how much money does this model help us to make? And the problem with that is that keyword help, because how do we divorce how good the model actually is from the strategy that is being used to place that model? The staking strategy, the various different other aspects that are important. And there's very similar things and questions that you might come up with for other domains other than betting. So it can be very, very challenging, I think. I think, as I summarize on slide 32, there's rarely a single model that's best. We basically need to avoid sensitivity to any particular data set. We need to have criteria that we can defend and that we can we can explain why we've chosen a particular data set, and we need to always be pragmatic and bear in mind what the final purpose of using the modelling that we are doing is for. And so really what it comes down to, I think, is practical data science rather than theoretical data science. And sometimes that can lead to multiple models. Multiple criteria can lead to multiple models. And sometimes those models can be inconsistent. For example, if we're trying to predict various different things about a football match, we might have one model that is particularly good at predicting the total number of goals in a game, whereas we might have another model that is particularly good at predicting the difference between two teams' ability. So the goal difference, for example. And those two models may be inconsistent. And so then we have questions of how important is that inconsistency. Do we want to do something like ensemble modelling, where we actually start combining models back again, various different models? And often, certainly if you look at machine learning literature, that can be a very useful thing to do as well. The next thing, and the last thing that I will talk about in the last 5 minutes, is basically looking at empirical models. And actually, this is a challenge in all kinds of domains, I'm sure. But it's kind of prior elicitation, if you use a Bayesian term. But basically, domain experts, whether they're coaches, people who've played before, existing players, they have a lot of expertise. They know and they understand their domain, their sporting domain. It may even be people who are very good at betting, who know how to make money from betting, but aren't traditionally statisticians or data scientists. So they've got a lot of experience, but they can find it very hard to encode it. And in my experience, where it is encoded, it's often in the form of a spreadsheet, which is lovely. So you'll often get a very complex spreadsheet. I've got an example of one in the following slide, I think, which it was kind of like nearly a gigabyte big, which for a spreadsheet is quite big, and takes about 5 minutes to load, and has lots of expert insights, lots of black box constants, no history, no kind of context of where any of those constants have come from, and that in itself becomes very hard to scale and very, very hard to assess. But it's often very performant in as much as it does a good job of actually doing the modelling, because it has been tailored by someone who really knows and understands what they're trying to model. So moving on to slide 34, this is a nice picture of just such a spreadsheet that I inherited, and it's kind of I can whiz through these slides, but this shows the kind of the process. I'll often inherit a spreadsheet from, this one was from the top sports scientist for the ECB, the English Cricket Board, and he's a very good mathematician. He's got a maths degree from Cambridge, but that, his way of doing maths is using spreadsheets, and he does it very effectively. And he knows cricket incredibly well, and he's coded up a lot of information within this spreadsheet. However, what you inherit are a lot of formulae that you have no way of tracing back, and not much more, and you have to reverse engineer it. So typically what that looks like for us is there's a phase where we collect the data, where we do some parsing, where we do some data processing, and this is nothing more interesting than a screenshot of some databases. But that is to highlight the fact that actually the first step for us is actually to look at the data. So typically in the empirical models that we inherit, those databases are all just behind the scenes in another sheet on the spreadsheet that we get. They're all in there. There's no real way of updating that data unless you manually go in and add some more data yourself. Whereas actually what we need to have is a data pipeline that refreshes the data on an ongoing basis, that is up to date, that is automated, and has as little user intervention as possible to make sure that it's kind of as scalable as possible. So having got the data, then what we'll typically do is turn it into code, into actually trying to code up those models, all those formulae into a spreadsheet, into the modelling framework, into a more general modelling development kind of cycle. And this is just some screenshots from some Python code that we had from CricViz that does that, not very interesting in itself. And then once you've got your models and you've done that model development cycle, you've got to make it available. So when we're providing something for our mobile app, or we're providing something for a broadcast person, we've got to actually make it in a way that whoever's developing that broadcast or developing that graphic, whichever third-party company that is, they can actually they can kind of query the data that we're producing in a robust and reproducible way, and that's typically through an API. So we develop APIs to disseminate our data. And the final thing the customer will actually see is an app or a graphic. And so what our bosses will typically see that we do is they'll see a spreadsheet and they'll see an app, and they won't see any of the bits in the middle or have any real understanding of all those bits in the middle that are necessary to get from one to the other. But actually there's quite a big pipeline in the middle. So as I said, as I touched upon before, assessing models is difficult. Working with empirical models can be very difficult, and they're very, very good. Trying to assess empirical models is incredibly difficult because you've got all the usual challenges of kind of robust models, but there's so much manually inputted data and manually inputted expertise that it's really hard to objectively assess that, and certainly post hoc to do it at any scale. You can't ask someone to kind of run their models after the fact and try and historically populate their models because they've already observed what's happened at that point. So it can be very, very difficult to assess and to assess these empirical models. And the best way that I've found to do that myself is, again, similar to kind of credibility, is to try and build up a model that mirrors the empirical model that you inherit as closely as possible, that automates and scales all those manual inputs as closely as possible, and then go back and on the matches where you've got both sources to compare them and actually say, okay, well they look very similar. Where you can, then go back and scale, run that historically in a very rigorous way, and you can assess that. And then going forward, actually look at where the additional user input, this extra inputs, so that very small handful of games, seeing whether, essentially anecdotally, whether that adds any extra value. But it's a very significant challenge. What's the future? I'm going to skip over this very quickly. Basically, I think the future is it is great largely because there are so many different opportunities out there. So I'm on slide 41 at the moment, but data as a society, we're getting a lot more data tolerant, we're getting a lot more engaged with data, and we're getting a lot more data literate, and that is moving straight through to sport. And so there are lots of various different opportunities that are not necessarily just the kind of predictive modelling of sport that I've talked about largely in today's talk. I'm going to skip straight to slide 44. I think predictive modelling in itself is changing because of the increasing amount of data. Typically, data for sports has not been big data, but now actually because there's much more data, because there's player tracking data, for example, there's odds data to the sub-second. There is now big data, and big data demands different ways of analysing it, and perhaps parametric models are not always the most effective ways to do that. So I think there's different ways of analysing data will come to the fore, and I still think there's a role for predictive modelling and for parametric modelling, but it may not be in betting, because I think the marginal gains in betting, at least from trying to identify opportunities where you might get a positive expected return, I think that actually machine learning and more artificial intelligence-based ways will probably take advantage of the big data in a way that parametric modelling will struggle going forward. That's my personal view. think the challenge with that, though, is to retain interpretability, because interpretability for betting is incredibly important, and actually that's something where a lot of the machine learning, the deep learning methods, you lose that interpretability, and that's obviously a very significant issue. And my final slide, I've got some really interesting things that I've been looking at, or I've been talking to some various people about. There's some ball tracking, as I mentioned before, for coaching applications. Amazing work being done in basketball at the moment. There is a company called In-Crowd Sports. They're doing some fan engagement stuff, and they have got some really interesting data that's kind of not really sporting data, but it's data of sports fans, and seeing how they interact with their team and their club, and how they move around the ground, how they interact with each other on match days, whether they're at the ground, whether they're at home. And that is a hugely interesting data set, and a very big data set that could be very interesting. So that's a different application of tool. And then there's another company called Smartodds who are doing some really interesting things with natural language processing, summarizing various different news articles about sporting events, and then adding on kind of some generative modeling where they're adding in their own tone of voice and their own kind of brand matching to kind of serve up content, automated content to various different outlets. There's aggregated facts and statistical content from other places. So I think there's some really interesting new challenges coming up. So apologies that it's been quite a bit longer than I anticipated to talk. Thank you very much for giving up an hour of your time when you probably didn't anticipate giving up quite so much. I guess my last slide is really to say, please ask any questions that you have. I'm not going anywhere. I should say thank you to Dixon and Coles, whose equation I copied and then wrote down incorrectly, and to the various companies that I've worked for and that I don't any longer work for, where I've kind of talked a little bit about some of the things that they've done. And also thank you very much to the RSS, both the sports section, which kind of I'm involved with, but also the PSF for inviting me to speak.
Really good talk, really enjoyed it. Obviously, area of interest for me. You talked a little bit about the kind of parametric models. What's your views on kind of just modelling the market, kind of the stuff that you said Stratagem were doing in the kind of time series stuff? How effective do you think those kind of approaches are?
I think they can be incredibly effective. I know a lot of groups, again, anecdotally, I know a lot of groups who are doing that kind of modelling. So one of the big financial kind of strategies now, it's quite an old-fashioned strategy, is called momentum modelling. So basically, it's trying to work out where there are turn points in the market and turn points in the pricing series. And I know definitely that there are groups doing similar things for horse racing, have been doing that for quite some time, being quite successful with that. And I think something like horse racing, which is a sport that's actually quite difficult to model in and of itself, is a good example of where you might be more useful to try and model, from a data science point of view, to try and model the underlying odds than to try and model the sport itself, because the sport is so affected by tactics and strategy that it's very difficult to capture from the data that's available.
Some of the stuff you've done with clubs is really interesting, and that kind of reticence of people, in that sporting atmosphere to accept kind of the data side of things. Obviously, you did it a while ago, and you talked a little bit about where it is now. There's a lot more people doing kind of data science in many sports. Where do you see it going? How far do you see it going in terms of how much kind of influence can the data people have on sports?
Well, I think that's a really good question. I think it's a really good point to illustrate it. In five years ago, when we did it, there weren't many people doing it. And now there are plenty of other clubs who have very significant data science departments. So Manchester City, for example, have a very significant data science operation. And then there are clubs like Brentford, for example, who we both know through our previous boss, who is the owner, who have invested very heavily in this approach to analysing clubs. I think it's a really difficult your question, I think it will always be hindered by the fact that there is a lot of irrationality in and around professional sports amongst the fan base. So the managerial thing was always a significant thing. We had quite little traction with that. We talked with a number of clubs about that, but actually what it came down to is the fact that the owners or the decision makers, the boards, were quite happy to acknowledge that they were prepared to make irrational decisions to appease a fan base. And I think that all the time you've got that there, then it makes your job in trying to kind of sell something that is purely data driven much more difficult. I don't think it's impossible, and I think that it's an issue of time more than anything else. I think that as you get success stories, then more, it will increase and the usage will increase. I don't think it will ever be or ever should be the only approach that should be used with data science. I think data science is an important part and an integral part of the process, but it is often very difficult to encode, to elicit expert knowledge, and I think there's a role for both things to work alongside each other. That's my personal view. What do you think?
No, I kind of agree. I think maybe football's a bit behind the times.
Yeah.
Compared to maybe the Americans and a lot of other places who are using data, we probably don't know so much about it, but maybe it'll catch up. I don't ever see a statistician as a football manager, but we've got statisticians, data scientists, heads of kind of directors of football, things like that. It's an area where I think data can have an effect, and like you said in your talk, as we become more data literate as a kind of community, it will just catch on more and more. So.
Yeah, I think that's right. I think that's a really important point that you made there, that actually football is a really difficult sports model to start with, because, and it's like a lot of team sports, but there's a lot of correlation between the players and what they're doing, and actually determining signal from noise is an incredibly difficult exercise. So actually, if you look at something like cricket, it's a much, much simpler proposition, because essentially you've got many repeatable events, and actually determining effect is and the effect of one or two particular players, the bowler and the batsman, is much, much easier than it is for football. So it perhaps is wrong to judge everything on the basis of football. It's perhaps natural that would be further back, because it is a very difficult sport to analyse. But yes, like you say, in the US, a lot of the US sports have embraced it a lot more. Hopefully you all really enjoyed that talk like I did. I'd just like to thank everyone for dialing in, and thank you very much, Dave, for giving that great talk. Thank you. Very much, everyone.